Hello, this is Rex and this is Project 2.1 Digital to Analog Conversion. As you can see here, this is a 4-bit DAC. DAC stands for Digital to Analog Converter. What this circuit does is it converts a digital signal, which in this case is the 9 volt coming from this power supply right here, into an analog signal that shows on this light bulb right here. Since it has 4 switches, and each of these can be represented as a bit, starting from 0-bit all the way to 4-bit. It can have 16 different analog signal outputs. And here's a quick demonstration. The process in which this circuit converts the digital signals into an analog signal is by using this R2R resistor ladder. So in this circuit, the resistors that are being used are 5.1 Ks and 10.2 K ohm resistors. The way that this R2R resistor network works is if I flip the first switch, it would output voltage divided by 2, which is around a 4.5 volts output, which once it passes through this resistor, it becomes voltage over 4, so that would be 2.25-ish. And it basically gets divided by 2 as it goes through both of these resistor networks. The output over here is the original voltage, which is 9 volts, divided by 16, which is why this light bulb, you can't actually see it turn on. Now, however, if we turn on this, then there would be voltage divided by 8, which is 9 volts divided by 8. And once you turn this on, that would be 2.25 volts, which you can actually see. And since we have all of these different configurations, we can then have those 16 different outputs. Over here, I have a 8-bit R2R ladder DAC. And over here, I have a op-amp, which is supposed to amplify the current of this circuit. Now, for this chip specifically, the lowest it can output is 2 volts. So unfortunately, the LED will stay on even if none of these switches are turned on. So due to this R2R ladder being 8-bit, this now means that it has a total of 256 different analog outputs that it can be used to output this LED. Now, due to the op-amp interference, the LED won't always show the brightness changing, but here's just a little quick demonstration anyways. 2 new components introduced in this 8-bit resistor network is this resistor bank and this switch bank. So this switch bank basically compresses all of these 3-pin slide switches into this very compact format. And the role this bus resistor network plays in the overall structure of the DAC is to connect these switches to ground so that the R2R ladder DAC doesn't stop working. Now, another important part of the circuit is the op-amp. So this chip, LM741CN, is what the op-amp is made of. So what the op-amp does is it amplifies the current that is passing through this entire circuit, because even though the R2R resistor ladders does give the correct amount of voltage, current is not enough to drive this LED, and since the op-amp doesn't take any current, it can substantially increase the current passing through into the final output, which is this LED right here. This resistor was just added just in case the LED blows up. Thank you so much for watching, and I hope you enjoyed this video.